Well, good morning. My name is Larry Harris. I'm a volunteer with the Army Corps of Engineers, and welcome to Mill Springs Mill. My job here is to show people the mill, tell a little bit about it, the history, and answer questions about the mill. The mill was built in 1817. That's shortly after the American Revolution. The mill burned in 1830, and they rebuilt it in 1834 as a three-story mill. That's when they added the top two stories. The stone wall over here encloses the mill pond, and that's where they store the water used to run the mill. All right, it's a little dark in here. In fact, the lighting you see here today was just added a year ago. Before that, they really had no artificial lighting. And the reason for that is the flour dust is highly explosive, and you couldn't have a lantern or a candle in here for that reason. This machine is a loom, and they use it to make bags, and they made them out of hemp. The loom escaped the fire in 1830 because it was up at the granary up on the side hill and escaped the fire at the time. This bin is a modern addition to the mill, and this is where they store the corn that they grind here on weekends from Memorial Day to Labor Day during the summer. This would be filled at the beginning of the year, and today it's empty. The only thing left is a little bit of cornmeal that shows what it looks like after it's been ground. The mill is full of chutes and elevators, and that's what these rectangular tubes are, and there are a lot of them throughout the mill. These were used to bring the grain up and down in the mill. Of course, gravity would bring the grain down, and water power would be used to raise the grain in these elevators, and there are a whole lot of them in the mill. These buckets would be running off water power, and they would circulate the grain. The corn especially you had to keep dry, and if you didn't, it would ferment. And that's why they kept it going all the time, and that would recirculate the corn to keep it dry. These three machines were brought in around 1880. They're called wheat crackers, and these are what they use to grind the wheat into flour. There are three of them, and they work in series. The first one, number one, is on the other end. They would bring the wheat down, have it ground once for kind of a rough cracking, send it back up by elevator using the water power we talked about before, send it down to number two for cracking again, a little finer grind this time, send it back up by elevator, and down to number three for the final grind. Now, the wheat flour is, of course, very explosive, and the reason that they put this in is to add moisture to it to kind of keep the danger of explosion down. It's kind of a tea kettle affair, has a water tank in the top. You can see a sight glass up here to keep track of how much water is in it, and there would be a burner in the bottom. Now, they probably burn coal oil or kerosene, but of course you couldn't have an open flame in here due to the danger of explosion, so they would have glass enclosing this to keep the dust out. This is the set of stones we use today. They're underneath the cover, and the cover, of course, keeps the grain from coming out on the floor. There is an opening around the back for the finished ground grain to come out. Incidentally, this mill was in commercial operation until around 1950 when the dam was put in on the Cumberland River to make Lake Cumberland. And since they couldn't use traffic going up and down the river, that put them out of business. Originally, the corn would come down through this chute into this hopper on the top of the stones, down through that tube, through the hole in the top stone, and spread out between the stones and come out, of course, on this side as ground cornmeal. This wheel adjusts the spacing between the stones, and as I mentioned before, those stones don't touch, but they come very, very close to each other. This is what the stones look like that grind the grain. These stones were imported from France back in 1817. They weigh about a ton apiece. This looks like one stone, but it really isn't. It's pieced together, as you can see along this line. And probably it was made that way for ease in transport back in 1817. They brought it over in pieces, put it together, welded a band of steel around the outside, and they even added concrete on the top of it for extra weight. Now, this stone looks quite simple. That is, just lines, grooves in the stone, but it's really more complex than that. Each of these surfaces is tilted slightly to the axis of the stone, and they're all parallel to each other. So dressing the stone would be a job for a skilled craftsman. These stones had to be lifted about once a year, and they used this crane up overhead for that purpose. They tell me one man on a wrench on that nut up there can lift this 1-ton stone. I'm sure the man creaks and groans a little bit while he's doing it. These stones don't actually touch each other. They miss by a small fraction of an inch. The the bottom stone down here would have an iron shaft coming up through the center of it, and that would be driven by water power. On the end of that shaft would be ears like this that would fit into these openings on the top stone, which would of course lie down on top of it. By moving that shaft up and down, they could adjust the spacing between the stones. They're not allowed to touch because they would wear out very quickly if they did. The way it operates is the top stone will be turning, the bottom stone is stationary. It's very carefully leveled up from underneath. The corn or wheat, whichever you're grinding, would come down beside that shaft through the top stone, spread out between the stones, and come out along the outer edge as ground meal. This wheel is used to adjust the amount of water coming out of the pipe, and of course, adjust the speed of the wheel. The wheel runs at about 2 revolutions a minute. There are 2 kinds of mill wheels in use. One of them is called an undershot or an undershoot. That wheel sits in a stream and paddles on the wheel. The water strikes those paddles and turns the wheel. The other is called an overshot, and an overshot wheel, the water comes over the top of the wheel and lands in buckets on the wheel. The weight of the water is what turns it. This is not only an overshot, it's the world's largest. It's 40 feet, 10 inches in diameter. I think they made it 10 inches bigger than one in France, just for the bragging rights. This wheel holds 2 tons of water on one half of the wheel. I had someone ask me a few years ago, well, why didn't they fill the whole wheel? Well, obviously, if you fill the whole wheel, it wouldn't turn. You have to fill just one half of the wheel. And as I mentioned earlier, this wheel turns at about 2 revolutions a minute. That's once around in 30 seconds. Someone asked me a couple of years ago, if that runs at 2 RPM, how fast do the stones turn? Well, I didn't know, so I asked Billy, the miller here, and he didn't know either. So I got out my calculator and I traced the gear train all the way through the mill, and I calculated the speed of the stones at 150 RPM. We put a chalk mark on one of the stones to check that. Found out I was wrong. It wasn't 150, it was 158 RPM. So I was pretty close. Mill Springs, of course, gets its name from the 13 natural springs that come out of the hillside behind me here. I've been up there and looked at it, and it looks like there's just one continuous spring, but they tell me there are 13 there. The springs were discovered by Daniel Boone, and supposedly he suggested this as a mill site, and in fact there were 3 mills here at one time. There was the gristmill you see here today. There was a sawmill. They made quality wagons here, sold all over the United States. And there was also a carding mill. Now, most people have never heard of the word carding, C-A-R-D-I-N-G. Carding is what you have to do to wool or cotton in order to spin it into yarn. You see, the fibers, when you shear the sheep, are all twisted together. You can't spin that with a spinning wheel. So what they have to do is card that, and that means comb it out. And they used what looked like large hair combs, and that would be done by hand at first, and very laborious job, I'm sure. And once you get the fibers parallel with each other, then you can spin it into yarn. The first mill here was a carding mill, and they had huge wheels with these cards or combs on the side of them, and that would comb out the wool. The pipe outside here is what we use to bring the water down from the mill pond up on the hillside. There's about 1,000 gallons a minute comes out of those springs up there, and that would be brought down with this pipe. This pipe was installed around 1910, so it's been here a little over 100 years. Before that, they had a wooden sluiceway, and of course the water wheel was wooden at that time. In this box is where the ozone gas was generated. It has a large electrical generator driven by water power, and this generator would generate between 25 and 30,000 volts of electricity. On the left-hand end of the generator is a box, and in that box is a spark gap about 1 inch long. And when that spark passes through the oxygen in the air, it creates the ozone gas, and there's a pipe that goes up through to the second floor into a large tank up where they would fill that tank with ozone gas, pump in the flour, and it would come out bleached white. You know, I used to think, like most people, that people living a couple of 100 years ago weren't as smart as us because they didn't have cell phones, computers, jet planes, that sort of thing. But they're very ingenious people. And this machine is an example of the ingenuity of the middle 1800s. This is a machine that automatically bags and weighs flour. And the way it works is quite simple. There's a hopper on the top where the flour will come down through, end up in this tube and into a bag on the platform. I'm going to engage the gears up above, and when I do that and turn that wheel, the auger inside of here will be turning. Now the gears are engaged. Now, a belt would be turning this wheel, as we mentioned before, and since the gears are engaged, the auger inside of this tube will be turning, and you can probably hear it when I turn this. Needs some lubrication. Now, there's a rope hanging down the back that has a weight on it. When the weight on the platform, the flour in the bag, equals what's on the rope, it shuts itself down. That's the automatic weighing part of it. Notice the gears are opened up now. We're on the second floor of the mill. This machine is a sifter, and the way it works is there are two large iron wheels that are weighted on one side, and when they turn they cause this whole mechanism to shake. Here are drawers that are used for the sifting, and I'm not sure whether it was used for flour or for cornmeal. Again, on the second floor, this bin was used to store the flour before it was bagged. Above me is the tank that we talked about downstairs. This tank would be filled with ozone gas. They would pump the brown flour in and it'd come out bleached white. In front of me and behind me are two big bins. One of them was for storing wheat for making flour. The other was for storing corn for making cornmeal. In the milling process, a certain amount of chaff is created that's unusable. And this sifting machine would be used to remove the grain from the chaff, or the chaff from the grain. And the machine behind me, way up here on the side of the building, was a blower that would blow the extra chaff out the back window. I want to thank you for visiting us here at Mill Springs. In addition to seeing the mill, there are a number of other things to see. In front of me, up on the side hill, is the gift shop, which was the granary during the time the mill was in operation. We have a picnic area out on the point with a cannon on the end of the point, which was used during the Civil War. And we have a large boat dock down by the lake, so you can bring your boat right up to the mill. And again, I want to thank you for visiting Mill Springs.